Okay, so this is going to be a very introductory video on area, specifically triangles and special quadrilaterals. Um, we will get more into doing things with the area and more past like geometry level understanding in another video. This one is just the very basics of things you should already know coming into geometry, but just making sure you do. So the first thing we want to talk about here is just a reminder of what is area. Uh, so you probably would be able to tell me something like, well, that's a rectangle, so the area is base times height or length times width, which is great, but that's really not a what is area. That's what's the formula for the shape. So when we talk about area, we're talking about the amount of space that is taken up by a two-dimensional shape. And so we've got this shape here. This one happens to be a rectangle, and the amount of space that is enclosed in those four sides is the area of that shape. Uh, Now we want to have a couple of other understanding points here. The next big thing would be that we measure area in square units. So you've seen that we've talked about things like square feet or square inches or square whatever it is. What does that really mean besides the fact that you put the little I and the little 2 above it for square inches? Well, when we talk about measuring these in square units, we're literally talking about a square. How many of these little 1 unit by 1 unit squares, so like maybe it's 1 inch by 1 inch, or maybe it's 1 foot by 1 foot. But we measure these in squares, so they're perpendicular edges, both the same length. They're squares, and we talk about like how many of these will fit, and we could literally set them all in and count them. But what we learned back when you first started talking about multiplication, you probably learned about area models for multiplication. And so this is the idea that if I took an array of rectangles, made an array of squares and made them into a rectangle, if I know that there's 3 units this way and 5 units this way, well, 3 times 5 means that there are 15 units, 15 square units in that rectangle. That's the same concept as area. So if we can know how many units long by how many units wide, we can figure out how many squares, 1 unit by 1 unit squares, fit inside of that shape. And that is the area. Like I said, found by multiplying. I did not leave myself enough room to actually put these on here, but found by multiplying 2 perpendicular lengths together. So you're always taking a base times a height anytime you're figuring out your area. And so for a rectangle like this, it is just base times height. It's a rectangle. Now, when we move on to something like a parallelogram, you've heard our area formula. Area equals base times height. It's the exact same thing as a rectangle. Obviously, this is not a rectangle. When we look at these parallelograms, this is the height, this is the base, this whole thing here is the base, or this whole thing here, doesn't really matter. Why is it still the same base times height, and why does this, this side length have nothing to do with it at all? Well, if I take a look at this triangle here that makes it a parallelogram and just drag it to the other side, I haven't changed the area because the area of these two pieces is still the area of the whole thing, but it's a rectangle now. So it's the height times the length of the base. This specific side length here does not matter at all, right? It's the perpendicular height. So that idea that we take the base and the height, and they have to be perpendicular to each other because we're making those square units. Base and height always have to be perpendicular. Area of a parallelogram is just base times height. Next up, we've got triangles. We all know the area formula for a triangle is 1/2 base times height. The big thing is, well, why is that? So if I take my triangle here, I've got, before I do that, let me go ahead and put the base and the height in. So there's my base, there's my height. Right? And base and height have to be perpendicular. The base does not have to be on the bottom. If I turn this whole thing around, it doesn't really matter. But the height does have to be measured from the top of the triangle, perpendicular to the base. I say top just because it's the top on this one. But why is it 1/2 base times height? So I'm going to go ahead and duplicate this one real quick and flip it over. And when I line these up, you'll see, well, that triangle is just half of a parallelogram. The area of this whole parallelogram would be base times height, but I don't want this part of it. I just want the half that was the original triangle. So that's where we get the 1/2 times base times height. So that's where the triangles come from. Other shapes you've seen, trapezoids, you've probably seen this area formula even if you don't remember it. The area is 1/2 times the sum of the two bases times the height, which is a little bit weird. This is the only area formula really that we add together. So our two bases, base 1, base 2, does not matter which one's which as long as we understand bases are two parallel sides. And then we've got the height. Again, the height has to be perpendicular to the base. That is the whole idea. These sides here do not matter. So the length of those two sides has nothing to do with this. But why is it base 1 plus base 2 times height? Where did that come from? So again, if you're getting any of these other shapes, especially with the half in there, all that's coming from is what happens if I duplicate this, make an exact copy, and just flip it around. Well, now I've got, you see if I can put these together, I made it a little bit too big there, but it's a parallelogram. And most importantly, this length here was base 1. So I can just take that. Well, that's base 1. The length of this entire base of my new parallelogram is just base 1 plus base 2 times the height. Gives me the area of the whole thing. But I only want the original one, so I only want half of that. I don't actually want this piece right here. I only want the original. And so that's where the area of a trapezoid comes from. It's just half of that doubled trapezoid that made a parallelogram. And the last one we've got is just a kite. You've probably actually never seen this area formula before, be my guess, but there's a formula for 1/2 times d1 times d2. So again, it's two dimensions multiplied together, and the diagonals, d1 and d2, have to be perpendicular to each other, and they are in a kite or a rhombus. And so we're still doing that same thing of multiplying two perpendicular linear dimensions. But why 1/2 d1 times d2? Well, if I just kind of draw a rectangle to fit around my kite, the area of this rectangle would just be base times height. Well, the base of this rectangle is just d1. Put this up. If this one here, we call that d1, and this one here, we call that d2, then the height of this rectangle is d2, and the base of this rectangle is d1. So the area of that whole rectangle would be d1 times d2. But if you look at this, each individual little quarter, they're not actually quarters, but each individual piece of this has been cut in half. We want the piece that's in the kite. We don't want the piece that's out. So we only want half of this total rectangle. That's why we have this 1/2. Basically, anything that's not a parallelogram or anything that's not a rectangle, the area formulas just come from the fact that we can chop them up and make them into rectangles, or double them and make them into rectangles. And that's why you see a lot of those 1/2s in there. So if you ever see that 1/2 in an area formula, that's where that's coming from. So I just would want to do a couple of quick examples here. You've been finding areas probably since elementary school, but just a quick example. There's one it's a triangle. So if I was going to find the area of that triangle, I think it's always a good idea just to start out with writing down the area formula. So since this is a triangle, it is 1/2 times base times height. And then we've got to plug in our dimensions. So 1/2. Remember, the base and the height, the most important thing is they're perpendicular. The base has to be one of the sides. So in this case, the base is 3. And the height has to be perpendicular. So it's the perpendicular distance from the base to the opposite point, the opposite side. So 2.8. Does not matter that the base is not on the bottom. Does not matter that the height is written outside of the triangle. It's just the distance from the base to the other side measured perpendicular. From there, we could go through and simplify that by hand. We could use something like Desmos to make it pretty easy. I'm going to tend to go with Desmos here, so I'll pull the calculator over on the screen for you. The nice thing about Desmos, we can just go ahead and just type it in. It's going to be 1/2 times the base. You can put it in the parentheses if you want, times the height. It'll help if you type the 2 though. And there's my area, 4.2. If they give you one of the sides as a decimal, leave it as a decimal. But Desmos can, of course, do things as fractions if one of the sides is given as a fraction. So 4.2. And since our lengths were measured in meters, we have square meters. Usually you will read this as square meters. Again, I want you to kind of be thinking of that fact that these are literal squares, 1 meter by 1 meter squares that are fitting into this. But of course, you will hear people read that as meters squared as well. It's not at all wrong. I just like to read it as square meters personally. One more quick example here. Let's just go ahead and do a trapezoid, since that's a little bit more difficult one for most people. So again, I always start out by writing down the area formula. You should have these, especially the trapezoid. Most people don't expect you to memorize the trapezoid formula. Even on things like the Iowa assessment tests, they're going to give you those formulas. And then start plugging things in. So I know the area is equal to 1/2. My two bases, does not matter what order. 1.4 plus 4 is the only plus in an area formula, times 3. I can do as much or as little of this simplifying as I want. I could literally go ahead and just do all the simplifying myself. So 1/2 times 5.4 times 3. I could go and multiply all that stuff out, or I could just rely on Desmos. You know, a good scientific calculator, any scientific calculator will just let you type that in. So I'd have 1/2. Do put that in parentheses, because we want to make sure it's doing our order of operations correctly, because we need it to add those together first. The only way you add first is if you stick things in parentheses. Times 3, we get 8.1. So 8.1 square inches. Just going to go ahead and write that out. That's square inches. And there you go. I'm not going to go ahead and do the rest of these, but the next video will be on what happens if we want to go backwards. What happens if I tell you the area, and now I want you to go back and actually find one of those missing dimensions. So we're going to add some algebra to this.